To review our 5 practice problems for today, what does mega stand for? Mega, capital M, stands for million, times 10 to the 6th. What unit is this? This is micro, 10 to the negative 6, and G stands for gram. Note that the standard unit of mass is the kilogram. This is a microgram. It will need to be converted. 184 millinewtons converts to regular newtons. That's one prefix. That's 184 times 10 to the negative third, which if you put it in your calculator or move the decimal 3 places this way, gives you 0.184 newtons. If you got that correct answer, then what you're doing is working. Use it. If you didn't get the correct answer, here's how to show your work. Times on the left-hand side. This is 184 times. What's milli? Look it up, memorize it. That is 10 to the negative third power. Right side, on the other side of the arrow, is divide. Divide by what? This metric prefix right here. The number right in front of the newton. There's nothing in front of the newton. It's plain newton. Fantastic. That's 1, and that's how we get 184 times 10 to the negative third, which translates into 0.184 newtons. If you're not getting the right answer all the time, use the times on the left, divide on the right, and show your work. Show your work here too. 2.0, there's a decimal, so we can't lose the 0.0. Somebody measured it. It's not 2, it's 2.0. 2.0, N is nano, G is for grams. Convert to, set it up so you have it later, kilograms. 2.0, keep that decimal in place. Nano, look it up. It is times 10 to the negative 9th. That's very small. Check size in your head. Divided by, that's the other side. Now we have a metric prefix. Metric prefix is K. Look it up, memorize it. K stands for 10 to the third. This is the kind of problem where if you're lucky, you can type this in and get the right answer, but the calculator is liable to give you the wrong answer. Use machine language if you want to be absolutely sure of the right answer. 2.0, use the E key. E what? E negative 9. Divided by, well, you just want 10 to the third, so that's 1 E3. Notice E is times 10 to the. Type that in. You will get the same number as you get doing by hand. Negative 9 in the numerator, 3 in the denominator. Denominator is also negative. Either way, that's going to be, calculator says 2e negative 12. The calculator's rounding, we know not to round. That's 2.0 e negative 12, or 2.0 times 10 to the negative 12th. What's the unit? Don't forget the unit, kilograms. Now you're done. This is a unit conversion well done. If you want to write this, I will accept this in my class. I can read machine language. Personally, I think this one is classier. This one we said in class. This number is rounded. It wasn't even measured. It was read off the box. This has no decimal points at all. It has one significant figure. It's on the scale of tens. Adding a whole lot of decimals to something you've never measured, adding teeny tiny milliamps and microamps, probably if we count 9 numbers here, they're even nanoamps, to full tens of amps, it's not going to make any difference. That's a worse difference than you already measuring it. Add these numbers together, you will get 20.00236233740, and no one will care about these because this was a gross approximation. Your last step will be to round, and when you round, you're going to get about 20 amps. Want more practice? Fantastic. Here it is. I am willing to put more time and more practice into the schedule if it looks like people need. If you need more practice, pause the video, work these problems, see what you get. You're looking for 3 things: facility with metric prefixes, being able to read them, being able to write them, knowing what they are; converting metric units, getting them into the right number of units, such as meters, seconds, kilograms, Kelvin, amperes, joules, watts, you name it. And third, knowing when to round your answer. Look, how many decimal places are there? Is the measurement approximate? Is it precise? Is it super precise? If your measurements are approximate, it's more accurate to round. Pause the video, press play when you're willing to check your answers. Ready? Giga, metric prefix 10 to the 9th, aka billion. This is a nanometer, that's 10 to the negative 9th. Showing your work, 300 microamps to amps. That's 300 micro is times on the left, that's 10 to the negative 9th, divide on the right. Well, there's nothing on the right but the unit, so that is 300 times 10 to the negative 9th. Type it into your calculator or do it in your head. 2 zeros on the top, 9 on the bottom, that's -7. No decimal points, so we don't need the zeros. That's going to be 3 times 10 to the negative 7. What's the unit? We're not done yet. Amps. Now we're done. Any way you got this, you're doing it right. Next one, again, show your work. Write it out. Times on the left, divide on the right. We've got 2 prefixes this time. This one is nano. Hey, I'm getting good at this. It's 10 to the negative 9th. And this one is kilo. That's 10 to the 3rd. Again, there's a decimal place, so we gotta keep those zeros. Type this into the calculator. It's going to be 4e negative 9 divided by 1. Use that double E key, 3, to make you get the right answer. Either way, it's going to be negative 9 in the numerator, another 3 in the denominator, that's negative, and it's going to get 4.00, keep those zeros, e negative 12, or times 10 to the negative 12th. I'm done. Wait, no, I'm not done because I forgot the units. Now I'm done. Now, this is a physics problem. It has an operation. It has algebra. All right, it's not so bad. You just add up the 4 numbers. But look at them before you start typing. Are they rounded? Yes. Which one? The first one. How many significant figures? 1. This is 3,000 to the nearest 1,000 compared to this, which is negative 4,000, etc., etc. This is milli. This is less than milli. This is near to the nearest hundreds of micro. Somebody measured this insanely precisely. In fact, they're so precise. If this is a truck, micro units aren't going to do. I'm casting doubts on the accuracy. I think this is one of those radar guns like we played with on the first day of class that says you're running at 30 miles an hour. I don't believe this. This one seems to have been estimated. And these two are somewhere in between. So when I type all these into the calculator and press enter, oops, sorry about that. I had a stray negative sign here. Apologies, I've been typing in a hurry. Go back to what you entered in your calculator. This is going to give you a different answer. I'll do both of them. The original problem as typed gives you this, round to 1 significant figure to the nearest 1,000, because that's the best measurement we have. It's about negative 8,000 kilograms of momentum. That's a lot. What does negative mean? My hypothesis is that negative means backwards. talking to the people in the 4th period class meets on A days, they will confirm that negative means backwards. However, the problem I intended to assign with 2 negatives and 2 positives gives us a grand total of about 90. Again, round to one significant figure. This last decimal is not doing anything useful, given that this first trucker never even measured, and this one had equipment that was so twitchy as probably to be faulty. This one is about 90 kilograms of momentum, which is not that much on a scale of 3,000. It's got positive forward momentum, but only a little bit.